All right, now we're using our next method to solve quadratic equations, and this is solving using the square root property. So when I see the square root property, I think plus or minus, plus or minus. So the reason that this works, just to kind of give you a simple example, I hope it's simple. If we're solving the equation x squared equals 9, what does x equal? Well, everybody's going to say x equals 3, and you're totally right. Right? Because we know 3 squared equals 9, and that's awesome, and that's totally correct. But there's another solution as well, which is x equals negative 3. And the reason is, if we take negative 3, that whole quantity, and square it, we also get positive 9, right? So if we're solving the equation x squared equals 9, yes, we get x equals positive 3, but we also get x equals negative 3. So the way I like to think of it is, if I were going through the steps to solve this, I would want to take the square root of x squared to get plain old x on the left-hand side, and I need to match it on the left and right-hand side. When I take the square root on the right-hand side, that's when I'm going to tack on that plus or minus. So the square root of x squared gives me x, the square root of 9 gives me 3, but that's plus or minus 3. So if you want to write 3 comma negative 3, that's fine. Or if you want to write plus or minus 3, that's also fine. That's a little bit of a shorthand. All right, and I just want to mention, as we're doing this, the first step, we want to isolate the squared, either a term or expression. So make sure you isolate the squared thing going forward. All right, so in number 3, we've got x squared minus 8 equals 0. First, I want to isolate this x squared. So I'm going to add 8 to both sides. So I have x squared equals 8. Okay, so now at this point, this is when I'm going to apply that square root property. I'm going to take the square root of both sides, but when I take the square root of that constant on the right-hand side, I'm going to tack on that plus or minus. So on the left-hand side, I just have plain old x. On the right-hand side, I'm going to have plus or minus whatever the square root of 8 is. And remember that the square root of 8 can be broken apart into the square root of 4 times the square root of 2, which is 2 square roots of 2. So I get plus or minus 2 square roots of 2 fully simplified. All right, for number 4, x squared plus 9 equals 0. First, I want to isolate that squared term. So I'm going to subtract 9 from both sides. So x squared equals negative 9. And now I'm going to apply that square root property. Take the square root of the left side and the square root of the right side. But when I take the square root of the constant, that's when I tack on that plus or minus. X equals plus or minus. And then when I take the square root of negative 9, because of that negative under the square root, this is when I'm going to pull out my I. So I know square root of 9 is 3. And then with that negative 9 under the square root, it's actually going to be 3i. So plus or minus 3i. All right, looking at number 5, x minus 5 squared equals 2. So in this case, I have a squared expression, a binomial that's squared. It's already isolated, so I'll go ahead and take the square root of both sides, tacking on that plus or minus on the right-hand side. So the square root of x minus 5 squared just gives me x minus 5. And on the right-hand side, I still have that plus or minus square root of 2. But I want to solve this for x, not for x minus 5. So I'm going to go one more step and add 5 to both sides. So this gives me x equals 5 plus or minus square root of 2. Oops. There we go. Now, be really careful when you're writing your answer here. I see a lot of sloppiness when you guys get to this point. So x equals 5 plus or minus the square root of 2. This plus or minus goes in front of the square root of 2. So we could have a positive square root of 2 or a negative square root of 2. So if I wanted to split this up into two answers, 5 plus square root of 2 or 5 minus square root of 2. Because we're adding positive 5 to both sides, that 5 is positive. It's never negative. So examples of wrong stuff that I see, sometimes you guys like to squish them together and you're like, ugh, I don't know, there's just a lot going on. I just want plus or minus 5 square root of 2. It looks so much nicer. I guess it looks nicer, but unfortunately it looks wronger. So don't just arbitrarily squish them together. Sometimes I see like a, square root of 2 plus or minus 5. You guys swap the order. But again, the plus or minus goes in front of the square root of 2, not in front of the 5. So don't do any sorts of weird gymnastics. The only thing I could see changing would be you could put, I'll put this back in blue because it's also correct. You could also put plus or minus square root of 2 and then a plus 5. So that would be okay. These guys would be okay. But just make sure that you're keeping the plus or minus in front of that square root of 2. All right, so number 6, we have 3x plus 5 squared equals 2. The squared expression is already isolated, so I'll go ahead and apply that square root property. So take the square root of both sides. When I take the square root of the constant on the right, that's when I apply that plus or minus. So this, ooh, that was weird. So this just gives me 3x plus 5 equals plus or minus square root of 2. Super. And now I want to go forward and solve for x. So I'm going to subtract 5 from both sides. So this gives me positive 3x equals negative 5, and then plus or minus square root of 2. And then finally, I want to divide the left side by 3, and I need to match that on the right side. So I end up with x equals negative 5 plus or minus the square root of 2, whole thing divided by 3.